Dr. Perez, I'm genuinely excited about today's conversation because what you are doing at PenAM sits right at the intersection of science, innovation, and compassion. We have patients from all over the world who ask about advanced alternative therapies and cancer vaccines. And I know you are one of the leading voices in this space. So, welcome to MediPocket Podcast.
Well, thank you very much for having me. It's a pleasure to be here.
Let's start from the beginning. Dr. Perez, what led you personally into oncology and what inspired the founding vision behind Pan American Cancer Treatment Centers?
That's a very good question. We originally started as, and primarily still are, a research institution. And we've been working on a variety of different forms of clinical research over the past 16 years. A little over 10 years ago, one of our research partners was also working on a variety of different immune therapies. And we started to figure out ways in which we could collaborate. It was particularly interesting to me because I actually have a deep family history with cancer. My mother is a 4-time cancer survivor, although if you ask her because of early detection, she would say 3. I lost my father, grandmother, and an uncle to cancer, and had a cousin that's undergone treatment. I myself had a few things removed because of early detection, thankfully. So it's something that's intensely personal to us, and having been both on both ends of care, I figured we could try and come up with ways of helping patients and finding innovative therapies that are less aggressive, help either mitigate or ease some of the effects of the current standard of care, and finding new ways of making things more effective and more efficient. The thing is, this is a condition that doesn't just affect the patient, it affects whole families, it affects caregivers, it affects friends, everybody around the patient. So if you can try to ease some of that in any way, I think it's incredibly helpful beyond just the medical standpoint.
This is a very scary word, and when you get this diagnosis, I think it just makes your world really like scattered, right? For the caregivers, for the patient. And it's so, interesting to see that you have a personal mission behind that. What breakthroughs in cancer treatment from the last decade excites you the most?
There's quite a few, actually. I'm partial to our research, obviously, the cancer vaccines themselves, but there's a lot of great work being done with CAR T cells. There's been a lot of innovations in various different ways of using dendritic cell therapy, checkpoint inhibitors, and a variety of different things. There's just so many new things out there that I'm thankful a lot of research is going into them. Unfortunately, it's very commonplace that new therapies will come out without adequate research or actual foundations behind them. They're being popularized and used as bad treatments. But because there is so much research being done on a lot of these, we're going to have some very valid data to figure out what works and what doesn't, and hopefully make some of these more commonplace.
Definitely need advancement, but you very well said there's sometimes a lot going without, proper, let's say, regulation, and sometimes a lot of information, which, sometimes the spread by the gurus around. What do patients often misunderstand about how cancer should be treated today versus 20 years ago? And I think that applies for patients and sometimes for physicians even.
Well, there's a lot of misconceptions out there. We get a lot of patients to say, you know what, I need to stay away from chemotherapy and radiation because it's all poison and it doesn't work and it just makes it worse and it kills you faster. Unfortunately, that's something that came out of a patient wasn't feeling well and they decided to be a little bit hyperbolic and people ran with it and it just kept spreading. I keep telling patients, were it not for an incredibly talented oncology team, state-of-the-art radiation, and very well-dosed chemotherapy, my mother's not around anymore. I am a huge fan. So when things are dosed appropriately, especially when we're talking about chemotherapy, when it's done based off of the specific needs of each individual patient as opposed to just a standardized dosing, it can be incredibly effective. It can cut down a lot of the negative side effects that you hear most about. And patients will say, well, yeah, but you're going to feel terrible. It's poison. It's going to change your life in all the wrong ways. I tell them, you know what? What's going to happen is you're going to feel pretty bad for a few months, but if it works, you get years of a healthy, active life. So yeah, you take a little bit of the bad to get a lot of the good. So just because you're on chemotherapy doesn't mean this is going to be the rest of your life. This is going to be what you're living through forever. It's a tool. It's a rough patch that will get you to something better. And fortunately now there's so many other therapies that you can combine with these things. Like I said, checkpoint inhibitors are a huge thing right now. Lots of different types of immunotherapy, our therapy included. And all of these can be used in conjunction. They can all work together synergistically and try to make things more effective and more efficient, as opposed to just putting all your eggs in one basket. Patients have a wealth of options now, whereas 20 years ago, you had chemo, radiation, or there's nothing to do.
So can you break down what advanced alternative therapy truly means scientifically?
It's a difficult question to answer. The use of the alternative, sometimes will give patients the wrong idea. They think, well, it's not traditional medicine. It's not Western medicine. This is going to be something a little, what's the word? I don't know. They're going to think it's going to be something new agey, something. It's going to be all plant-based. It's going to be natural. It's going to be something that I can cook up in my kitchen. It's going to be something that we're going to be using your food to treat you. It's going to be using supplements and herbs and all these other things. And they don't think there's any actual scientific validation behind it. And then that's like I said, a common misconception. It's called alternative because it's not at the moment the standard of care. So the standard of care is somewhat narrow. There are certain things that you can do because these are things that have been proven over decades of both use and research, and they've been improved upon over time. But as new therapies become available, they have to, again, go through that kind of gauntlet where you have to show that they're effective, you have to show that they're safe, you have to show that it applies to a certain percentage of the population that you're trying to treat before it can become a standardized form of treatment. Nothing starts out being, this is what we're going to do for everybody. Right. Same thing happened with chemotherapy and radiation and antibiotics for that matter. So it's called alternative to a point because it's not widely used. It's not used as the main source of care. But all of these new therapies that are coming out have to go through quite a rigorous documentation, experimentation, publication, peer review. And that's why you have so many clinical trials out there trying what are still considered alternative therapies, but all of them science-based.
That is really helpful, clarifying the difference, because truly, I think alternative is understood in a way that it's not the traditional, it's just something new age treatment. But these are just the pathway where any treatment, when become mainstream, it is an alternative before it becomes a mainstream. What differentiates PenAM's approach for traditional oncology, and which therapies in your arsenal have delivered the most promising results?
Well, you know what? The thing to understand here is our therapies, the way that they're designed, they're not meant to be standalone therapies. None of what we do is meant to be even your primary source of care. Our therapies are all adjuvant therapies. That includes the use of dendritic cells, that includes the use of vaccines, be it a personalized peptide vaccine or an off-the-shelf vaccine, any of the IV therapies that we can offer to help supplement both cellular nutrition and boost immune function, any kind of immune therapy that you can think of. It's not meant to be your only source of treatment. And that's something that patients actually get confused about. They'll see a clinic like ours, or they'll find something online. They'll think, well, this new therapy sounds very promising, and this is what I want to do. I'm going to ditch everything else, forget about what my oncologist said, forget about my medication schedule, forget about the therapies that they've suggested or anything else, and just focus on this. And then we have to come in and tell them, you know what, this is not the way this is designed. The idea here is not to change your current therapy schedule. It's to make it more effective and more efficient, and to do it in such a way where we can help either maintain or improve your quality of life while you're undergoing treatment, maintain as healthy a lifestyle as you can, and feel as good as humanly possible while you're undergoing the treatment that you're meant to be going through. Because while these therapies can be very effective on their own, which is true, it's not their purpose. And again, it's not applicable to every patient. Some patients are going to do great with just these therapies. Some patients, you're not going to have any effect. But if you combine them with traditional therapies, if you combine them with the standard of care, then you can make this very effective. In my experience, we use a combination of different kinds of vaccines. Sometimes we used a personalized vaccine with one or two different off-the-shelf vaccines that we have available. Some of them are geared towards reducing blood flow specifically to the tumor, some of them to make a tumor more immunogenic or easier to find by the immune system. Some of our therapies include the use of dendritic cells, like I mentioned before. And basically what you're doing there is increasing the number of circulating cells that are able to take up certain antigens and teach the immune system what to do, where to go. And if you treat these cells before you implant them into the patient, you actually prime them to be able to do this. But again, this is not something that's going to take care of everything by itself. This is something that's going to work in conjunction with whatever therapy's already been designed and hopefully make it a lot more effective.
Important because people like to go for something standalone, right? They feel like it to be, oh, this is going to be that magic wand that doesn't need any other, things in conjunction with it. Personalized cancer vaccine is something that is getting very popular in a way where people are getting very curious about it and would like to understand what different types of personalized cancer vaccine are and what exactly the personalized cancer vaccine means.
There's a lot of different ways of coming up with what you use in a personalized vaccine, but once you actually have a list of what you need, then pretty much all vaccines are created somewhat equal. What you have is a collection of peptides. Now, the way that you come up with this list of peptides that you require is a patient will undergo biopsy. And then once you have that biopsy, that tissue gets sent to a lab that can do a complete genetic workup. And from that genetic workup, once you have all the raw data, there are bioinformatics algorithms that you use to come up with what is called a neoantigen prediction. Now, this neoantigen prediction is the list of peptides that we use to create the vaccine. But basically, it's a list of, peptides are basically fractions of proteins or sets of amino acids, specific amino acid sequences. Basically, they are genetic markers, and they are unique to each individual patient's tumor. So think of it kind of like a fingerprint for that tumor. No other tumor is going to have that exact peptide profile, and they might not have any of the peptides that are mentioned in one patient's profile. So what we do is we get that list of peptides, and we can actually have them produced in the lab. We can have them synthesized. From that, we can create a vaccine, and the purpose of this vaccine is to teach the immune system to go after the specific genetic markers of that patient's tumor. Now, the reason why this is becoming so popular, why there's so much research going into this, and why we feel it's effective, is because it bypasses the ways that tumors usually protect and defend themselves. So every human body will eventually develop cancer cells. It's just the way it is. But usually your immune system will find them and destroy them. It's what it's meant to do. There can be lapses in immune function for a variety of different reasons. And when that happens, some of these cells might just conglomerate, form tumors, and then these tumors will grow and learn to protect themselves. And to do that, they'll produce a certain amount of substances, including, let's say, IL-10, PD-L1, the things that will not allow certain immune cells to mature so that they can't bind them. And then they'll change their microenvironment. They'll cover themselves with a little bit of camouflage. That'll include anything from fibrous tissue to different kinds of immune cells that aren't working appropriately. Basically, a mishmash of different tissues and functions and substances that the immune system will be able to see, but doesn't recognize it as something specific that it needs to attack because it's not blinking red lights, right? So what we do with the personalized peptide vaccines is get around that, get around what the tumors use to hide from the immune system, because we give them a very, very specific and unique target. So I talk to patients a lot, and I do Zooms almost every day. And one of the things that I've started to do is use a lot of different analogies to try to explain this. So my favorite analogy to explain how these vaccines work is this. Imagine the human body as a concert venue. Now, the immune system is going to be the security force for that concert venue. Anybody that's been to a concert in the past 40 years will know you're going to have a security guard standing right next to you, and the guy to your left is lighting up a joint, and the security guard won't even bat an eye. He doesn't care. right? So what's happening is these security guys are walking around, they're patrolling it, but they're looking for something that's very overtly out of place, something really obvious. Some guy rushing the stage, somebody trying to start a fire, somebody beating up the concessions guy, somebody starting a fight in the mosh pit, something really, really obvious. Otherwise, they don't care. So they're not looking for every little thing, every little detail. That's why they don't care if the guy next to you has a joint or somebody else is sneaking in food or booze. So they're looking for something very, very loud. What we're doing, instead of having them just patrol around, is with these vaccines, we're telling the security guys exactly who they're looking for. We give them such a detailed description that it's basically like giving them a picture of the guy that they're looking for, height, weight, eye color, hair color, what the inside label on their t-shirt says, and where they're sitting. And that way they know exactly where to go, exactly who they're looking for, and they could just go do that, take them out, and you're done. This is what the vaccines do. It's not just boosting up the immune system and having 5,000 more security guards in there that are still doing the exact same thing. They're just looking for something really obvious. Instead, find the guys that are already there, tell them where to go, tell them who they're looking for, and let them do their job.
So beautiful. And I think you explained in such a, very layman term, because while you were just, telling that analogy, I was like picturing it out. And it's almost like you're giving a code, a secret code getting delivered through these vaccines to already the security cells that, or, the immune cells that we already have, and empowering them with the right information, where to go, who to go, and where to attack. Thank you for being so creative, because I think the patients, one thing patients feel from doctors is like the heavy words, is like, using those medical terms, and making them feel, understand really in the layman term. I mean, that's the power.
We feel a happy patient is a comfortable patient. A comfortable patient is one that is completely aware of everything that's going on. For that, they need to understand exactly what's happening. And unfortunately for us, not everybody has the background to go through very heavy medical texts and go through all the terminology. So if you can make it simple to understand, it's easier. And that's where we one of my favorite quotes is, if you are unable to explain something to a 5-year-old and make them understand it, that means you don't understand it yourself.
I also call it like involved care, because the patients generally, they just follow the direction, the prescription and all that without really understanding why. So they're not really involved in the care. They are really just following the instruction. Having them understand, as you said, as a 5-year-old can understand, is like getting them involved in the care. Talking about these targets, like you talked about how these vaccines are really work. Now, you talked about, some targets, but to ask you again a little bit in detail, what mutations or immune pathways does the vaccine focus on? And importantly, which patient or cancer types respond best to vaccines?
Well, the nature of a personalized vaccine is such that it's going to be based on the specific and individual mutations that each patient is going to present. Not everyone has the same mutation, and not everybody that presents the same mutation presents it in the same way. So that's why we get these peptides that are unique to each patient's tumor and figure it out that way. But there are, like I mentioned before, off-the-shelf vaccines that can focus on very specific targets that are common to other things. So just to mention 3. One is a VEGFR vaccine, which we use the name PenAM vax for that because, that's our name and we like it. That is geared specifically towards the VEGFR type 2 receptor. This receptor is expressed in cells that help create, maintain, and repair tumor-specific blood vessels. So if you attack the cells that have that specific receptor, you take away the ability for tumors to create and maintain their own blood vessels. In doing that, you reduce its blood flow, basically starving it out, and it causes oxidative stress and makes the tumor more immunogenic, makes it weaker, makes it easier to treat. That's one. So that's a very specific target. There is a WT1 vaccine that we use. WT1 is short for Wilms tumor 1. And as the name would suggest, it was first discovered in the Wilms tumor. It's the first peptide discovered in that tumor, but it's also found to be a very common marker in most solid tumors. Common to the point where most of them are going to present it. So it's just an additional target that you could use to have the immune system attack, kind of coming at it from all sides. Another one that we use, which is incredibly common in glioblastoma, but also found in a lot of different solid tumors, is the survivin peptide. Survivin, as the name would suggest, is basically a substance that tumor cells use to help themselves survive. It's how they protect themselves. We like to describe it a little bit as armor plating for a tumor cell. It's how they fight off attack. It's how they repair themselves. It's how they proliferate and grow. So if you whittle away at that armor and take it away, then you have basically a naked tumor cell that can easily be attacked. It's more vulnerable, more susceptible to treatment. So we do a combination of these things. Sometimes we'll use one or two of these off-the-shelf vaccines along with a personalized peptide vaccine. Obviously, this being done in conjunction with a patient's current treatment schedule and increase efficiency for everything. But the more you can weaken the tumor, the more you can chip away at its blood supply and its armor, basically, and then attack it directly using a variety of all these things, then the easier it is to get rid of it. As to what kind of patient is a great candidate for this, to be fair, when you're using a personalized peptide vaccine, since it is unique to the patient's tumor's individual genetic code, it doesn't really matter what kind of tumor it is. It doesn't care what tumor type it is. So it's not like this is coded to glioblastoma, this is coded to osteosarcoma, or anything else. It's a tumor. It's a solid tumor, and it has these specific genetic markers, so it's going to attack those specific genetic markers. So really, anybody with a solid tumor is a good candidate for this kind of treatment. We are unsure of the effects on blood tumors or blood cancers at the moment because we haven't done as much research as we would have liked so far. We have something in the works where we're going to figure out how we can use this for a variety of different bloodborne conditions. But at this point, we're pretty confident in the use for any solid tumor.
How about this for the pediatric? Is it the same effect for the pediatric patients, or is it still, for now, for adults only?
I tend to be a little conservative in this situation. We've been asked on several occasions to do this for pediatric patients, and I try to stay away from the younger patients because they don't have a fully developed immune system. And you don't know exactly how it's going to react. And if our therapy is based on using the immune system to carry out a specific activity and you have an unstable or unreliable or unpredictable immune system, then your results can be unpredictable. That's not to say that this could cause a negative impact or any kind of adverse event. It just might not be as effective. The advantage of this kind of therapy, these kinds of peptides, is that they're pretty innocuous. You're providing a target, and that's it. You're providing a blueprint, like I mentioned in the analogy of the security force. But it's not like medication. It's not where you have to have a certain concentration or it has to be metabolized or you have to have certain biochemical processes associated to it so it can work. It's just literally a target. Go look for it, go find it. So one of two things is going to happen. Either the immune system will pick up these markers, go do their job, and it works, or nothing happens. It's not going to make a patient worse. It's not going to cause any kind of reaction because, again, it's not something that's being metabolized in the liver. It's not something that has to go through the bloodstream. It's not something that has to have a process applied to it. It's literally just a marker. So either great, you have a positive impact, or nothing. In pediatric patients, like I said, we don't know if it's going to be effective. We haven't really geared it towards these patients because, again, we're not sure about the unreliable nature of their immune system. So let's say maybe 16, 17 years old, you have a more stable situation. We'd be more than happy to try that. Anything younger, I think, it has the potential to be wasteful. Not harmful in any way. It's just, it might not work because their immune system just might not take it up or might not do anything about it.